Greetings, Algebra 2 students. Today we're going to talk about recursive equations and explicit equations for sequences. Remember that an explicit rule gives a sub n as a function of the term's position number n in the sequence, right? So you can find the 100th term of a sequence without having to find 99 previous terms. But a recursive rule gives you the beginning term of a sequence, and the recursive equation tells how a sub n is related to one or more preceding terms. So let's talk a little bit about recursive equations. For an arithmetic sequence, you have a sub n equals a sub n minus 1 plus d, where d is the common difference. That's how we would write the recursive equation. For a geometric sequence, oh, that got smudged. For a geometric sequence, a sub n equals r times a sub n minus 1, where r is the common ratio. And you should reference these equations as you're doing your homework. You should write them down on a note card to help you remember them. These are important for this assignment. So let's consider this equation. Write a recursive rule for a sub n equals 5 minus 3n. Well, I'd like to start these by writing the first three terms of the sequence. A sub 1, 5 minus 3 would be 2, right? And a sub 2 would be 5 minus 3 times 2. 3 times 2 is 6. So 5 minus 6 is negative 1. And a sub 3 is 5 minus 3 times 3. The 3 times 3 is 9. So 5 minus 9 is negative 4. So what's happening? We're subtracting 3 each time, right? And that's given to us right there. That is our common difference, right? And so we need to write a recursive rule. And a recursive rule will look, remember, it's a sub n equals a sub n minus 1 plus the common difference. Well, we start by writing our first term. So a sub 1 is 2. And then a sub 2 is a sub n minus 1 plus, well, in this case it's minus, right? Our common difference is negative 3. So it'll be minus 3. And that is our answer for that question. Well, that was an arithmetic sequence. What about a geometric sequence? Like a sub n equals 10 times negative 2 to the n minus 1 power. Well, remember the formula. A sub n equals r times a sub n minus 1 for our recursive rule. Well, again, I want to write the first couple terms. It just helps me to visualize what's going on. What is a sub 1? So 10 times negative 2 to the 1 minus 1 power. Well, the 1 minus 1 is 0, right? And so that would cancel out, and you would be left with 10 for your first term. Well, what about the second term in the sequence? It would be 10 times negative 2 to the 2 minus 1 power. Well, the 2 minus 1 is 1. And so that would end up being negative 20. And a sub 3 would be 10 times negative 2 to the 3 minus 1. Well, the 3 minus 1 is 2. And so negative 2 to the second power is 4. 4 times 10 is 40. So we can see, you know, your first term is 10. You're multiplying by negative 2 each time, and that's evident in the equation, but this helps us to visualize it, I think. So if I'm writing my recursive rule, I would write a sub 1 equals 10, and a sub n, oh, I forgot. That should be an n up there, not a 2. A sub n equals r, which is negative 2, times a sub n minus 1. That's it for writing a recursive rule. Now, real quick, what if you have to write an explicit sequence? Remember, for an arithmetic sequence, it's a sub n equals a sub 1 plus n minus 1 times d, where d is your common difference. For a geometric sequence, it's a sub n equals a sub 1 times r to the n minus 1. So for this equation, or question rather, write an explicit rule where a sub 1 equals negative 1 and a sub n equals a sub n minus 1 plus 7. Well, again, I'm going to write out my first couple terms. So I have a sub 1 equals negative 1, a sub 2, I'm just adding 7, right, to the previous term. So if a sub 1 is negative 1, a sub 2 would be 6, and a sub 3, we're adding 7 again, so that would be 13. Okay, remember, we're going to use this formula. The a sub n equals a sub 1 plus n minus 1 times d. A sub 1 plus n minus 1 times d. And a sub 1, we know, is negative 1. Plus n minus 1, what's my common difference? In this case, it's 7, right? So times 7. Now we're not quite done. We need to distribute this 7, and then we need to combine like terms and simplify, right? So this is equal to negative 1 plus 7 times n is 7n, minus 7 times 1 is just 7. I'm going to combine the negative 1 and the negative 7. So I get a sub n equals negative 8 plus 7n. And that is our answer for our explicit rule. Have a good day. Don't forget to wash your hands.